This video is about parallel and perpendicular lines. The first important thing to know is that two lines are parallel if they have the same slope. So that's the first important thing. Let's do an example that has to do with parallel, and then we will go into perpendicular. So for our parallel line example, we want to write the equation of the line that is parallel to 3x plus 4y equals 5 and passes through the point -1, 3. So the first thing I'm going to do to find the parallel line is to find the slope of the original line. So my original line is this one right here. And I'm going to find my new line by using what I know about parallel lines, which means that I need to find the slope of the original line. So I am going to start by writing this in slope-intercept form. And I do that by solving for y. That gives me 4y equals -3x plus 5. I divide both sides by 4, which gives me y equals -3/4 x plus 5 over 4. Now, in this equation, this is still my original line. The only thing in this equation that I care about is this -3/4 x. This 5 over 4 you can cross out, you don't need it. We don't care about the original line's y-intercept, all we care about is its slope. So now my new line, the one that's parallel to the original, is going to have a slope of -3 over 4. And we don't know the y-intercept, but we know that it passes through the point -1, 3. There's a few ways you can find the equation of the new line. I'm going to use point-slope form. And if you remember, it's y minus y1 equals m times x minus x1. I'm going to plug in my point, plug in my slope. I get y minus 3 equals -3/4 times x plus 1. And you're going to solve that out. Use the distributive property. You get y minus 3 equals -3/4 x minus 3/4. You add 3 to both sides. And if you want to do 3 minus -3/4 off on the side, that's fine. It's 12 over 4. You would get 9 over 4 there. Whatever works best for you with adding and subtractions doesn't matter to me. So this is actually my answer. I'm just going to leave it like this in slope-intercept form. It's okay that we have fractions. And that's it. The second important concept here is perpendicular lines. So two lines are perpendicular if their slopes are negative reciprocals of each other. And I'm actually going to add a little thing. It has to be, both lines have to be non-vertical. We'll talk about vertical and horizontal lines later on. But you don't really even need to worry about that. Just remember they have to be negative reciprocals. For example, I'm going to just give you some. So perpendicular slopes, or slopes of perpendicular lines. For example, if you have -3 and 1 over 3, these two can be slopes of perpendicular lines. If you have 4 over 5 and -5 over 4, those ones would also work. If you have -1 over 8 and +8, those would also work. So those are examples of negative reciprocals. So let's do an example. We would like to find the equation of the line that is perpendicular to 3x minus y equals 8 and passes through -6, 5. So we're going to start with our original line, which is 3x minus y equals 8. We need to start by finding that line's slope. So I'm going to solve for y. By moving over the 3x, then I'm going to multiply both sides by -1, which gives me y equals 3x minus 8. So my original line has a slope of 3. Now my new line is going to have a slope that is the negative reciprocal of that, which is going to be negative 1 over 3. So now I need to find the equation of the line that has a slope of negative 1 over 3 and passes through negative 6, 5. I'm going to use the point slope form again. I get y minus y1, which is 5, equals my slope, negative 1/3, times x minus x1, which gives me x plus 6. Now I need to solve it out by using the distributive property and moving over that 5. That gives me y equals negative 1/3 x plus 3, and that's my answer.